First of all, I'm okay being wrong. And by the way, I'm wrong all the time. So having compassion for yourself for being mistaken at times, but also continuing to have the self-confidence to say, I believe in my own logic. I believe that this is going to happen. And that allows you to take certain chances.
Hi, everyone. Welcome to Behind the Tech. I'm Kevin Scott, Chief Technology Officer and EVP of AI at Microsoft. Today, tech is a part of nearly every aspect of our lives. We're in the early days of an AI revolution promising to transform our lived experiences as much as any technology ever has. On this podcast, we'll talk with the folks behind the technology and explore the motivations, passion, and curiosity driving them to create the tech shaping our world. Let's get started.
Hello and welcome to Behind the Tech. I'm co-host Christina Warren, Senior Developer Advocate at GitHub.
And I'm Kevin Scott.
And today we are bringing you an interview with Mike Volpe, who is an investor and tech leader, and he's been a part of 9 successful IPOs, including Confluent, Elastic, Aurora, Sonos, Slack, Pure, Zuora, Arista, and Hortonworks. Wow, that's a mouthful.
It's a lot of cool stuff.
No, I'm super looking forward to this conversation because, we rarely talk to people, or at least I rarely talk to people. You talk to people like this all the time. I rarely have an opportunity to, hear from people who have this level of experience and investment in the tech world.
Yeah, I mean, Mike is super interesting, in that he had such a long career at Cisco when Cisco was really at the center of the tech world. I mean, Cisco's still like an extremely important company, but it's just hard to overstate how important and central Cisco was as we were going through the internet boom, where, in a very, very, very short period of time, you had to figure out how to birth the modern internet, to get everybody in the world connected to it, and to get every business that already existed a presence on the web, and then to build all of the new businesses that the web created the opportunity for. And so Cisco at one point in time was just a fundamental part of the story that you were telling on all of those things. And like Mike was just dead center of all of that at Cisco for years. And I think it's, particularly interesting thinking about how that internet boom and like this massive infrastructure build out and like this massive scramble to go create a whole bunch of things that never could have existed before back then parallels what's going on right now in AI. And like, I think him as one of the most successful investors in AI, is no accident. So I'm just super looking forward to this conversation with Mike.
I am too. Let's get into it.
Mike Volpe is a partner at Index Ventures, a venture capital firm. He co-founded the firm's San Francisco office and North American operations, and he invests primarily in artificial intelligence, infrastructure, and open source companies. He spent over a decade at Cisco Systems, where he led acquisitions and built a strategy for mergers and acquisitions that's used as a model throughout the tech world. Mike studied engineering at Stanford, where he earned a BS in mechanical engineering, an MS in manufacturing systems, and an MBA. He serves on multiple boards, including Aurora, Confluent, and Sonos, and he's a non-executive director on the board of Ferrari. Mike, thank you so much for joining us on the podcast today.
So great to be here, Kevin. Thanks for having me as a guest.
Yeah, so you and I have known each other for a while. I have been especially looking forward to chatting with you today. And, let's just start with how you got interested in science and technology in general, because you had a really interesting childhood and upbringing.
Yeah, I had a little bit of a different, different upbringing than most people. So I was born, I like to say, a regular Italian kid in Milan, Italy. My parents are both from there. I lived the first 6 years of my life there in Milan, or the area around Milan. And then my dad got transferred to Tokyo He worked for a bank, and they transferred him as an expat over to Tokyo. And then I spent the next 12 years, almost 11 and a half years in Japan. So from basically first grade all the way through high school. And I went to American schools there, which is principally why I sound so American and not so Italian, disappointingly to my wife, of course. But the interest in engineering, I think, originally came from cars. I loved cars. I mean, I remember as a little kid, walls plastered with posters of Ferraris and Lamborghinis and Lancias and all that. And, you know, Italy's sort of the mecca for the supercar, sports car, hypercar thing. And, you know, it sort of started off with the idea of, you know, wanting to understand how those things worked and what the specs were and, you know, what a cylinder and an engine was and all of those things. So that's really the origin of it was there. I don't even know that I really appreciated it was engineering. It was just like a passion for these mechanical things that did amazing stuff and raced. So and I mean, my dad, when I was young, took me to Formula One races, which I thought was the coolest thing on earth. I went to Monza with him. I think, you know, he carried me around on his shoulder so I could see. Those are probably my first memories of
you know, it's really interesting though, because like a lot of kids, I think, like particularly in Europe, watch Formula One, you know, with their family or with their friends, and you know, it's not unusual for Formula One fans to look at the driver and say, "Hey, I want to be the driver." Like, do you understand what it was that made you look at Formula One and say, "Hey, I want to actually be able to make this thing"?
I think it was, I mean, I didn't dislike the drivers, but the Formula One cars I thought looked cool, right? They looked amazing, but I don't think that people meant for them to look amazing. They just meant for them to look fast, and the fast would turn into amazing, right? Like it was form followed function in some sense. And I was sort of fascinated. Like I would like design cars in the evening, like in my notebooks and stuff, to make things look cool. And actually there is something about in that era, because today when you think about how cars are designed, it's real engineering, it's wind tunnels and drag systems and simulations and all that. But back then it was the idea of looking fast was in the mind of a designer, of an engineer. And I think those ideas, and then, you know, the fact that, in the end, the fastest cars had the best engine. And so I wanted to understand, like, you know, if you didn't have that engine, you weren't going to win. And so it was sort of like, well, you know, it's the technology that's actually making these people win. And that's what got me interested into it. Yeah,
super interesting. You know, I'm also, you know, fascinated with, you know, your dad was a banker. What did your mom do?
My mom's a journalist.
Yeah. So, and like I don't mean this in any kind of way, but like, you know, they're not technical people, like not engineers, right? You know, so like, you know, like super highly successful people, but like your family or your immediate family wasn't a bunch of engineers. Were there any other influences? Like, was it just a pervasive culture thing? Like, I know both, you know, Italy and Japan are both amazing engineering countries, like particularly when we were growing up, like Japan in particular was like, you know, this ascendant industrial power. Did any of that influence how you thought about the world?
Neither mine of my parents have done anything technical, nor are they particularly good with tech. Apparently, my grandfather, who I actually have never met, he passed before I grew up, but he was a chemical engineer and was quite the engineering mindset. I think what happened to me was I liked these things. And then as I was going to school, I liked doing math. I liked the science classes, and that sort of self-reinforces, you know, and after a while you're like, oh, I'm a person that likes this sort of thing. So it wasn't so much that I was influenced per se, although in fairness, both countries, Japan, Italy, countries that build a lot of mechanical systems generally, In Japan, I was probably more influenced by the electronics part of the culture because the Italians are not, they don't have a great history in electronics, but the Japanese do. And I remember growing up a little later in life where, the Walkman was the thing to own. It was like the coolest thing. And once again, like I was the kid that would get the Walkman and like undo the screws and look inside and go like, oh, how do they do this thing? How do they make it? How is it that it's so small and it does these cool things? And so, I was always just enjoyed like how is something made was something that always just interested me.
Yeah.
And it got reinforced probably because the environments. There's actually, you might have been there, Kevin, but in Tokyo, there's an area called Akihabara where they have an electronics district.
Yeah.
And now it's a little, because the world become much more software than hardware. But at the time, my mom would take me there and you could just buy anything you wanted. Everything from resistors and capacitors, pre-made circuit boards, oscilloscopes, like anything you wanted, you could go get there. And I was like, I just loved it. Every time my mom would take me there for the weekend, I thought it was she thought it was incredibly boring, but I thought it was super cool. So it just sort of bubbled out of me, I would say.
Yeah.
But the environment helped for sure.
Yeah. And so how did you get from, I guess, high school in Japan to Stanford?
So my high school I went elementary, middle, and high school in English. So it was kind of obvious to go to an English speaking place to go to university. All the way through high school, science and math was my thing. So I wanted to go to a university that had more of an engineering orientation. US seemed obvious. It was cool. Like, the US where cool things were made. Like, the companies that we admired at the time, like I had my first computer that I had at school. It wasn't my computer. It was a school's computer, was a Commodore PET. It was like 64K or whatever I was. And it recorded on a cassette tape when you wanted to, storage was like literally a music cassette tape. And then I got a PC that was a NEC made IBM clone. And all these things were American, like Commodore was America, IBM was America, like all this cool stuff was happening. So going to America was sort of the obvious choice. I applied to a couple of schools on the East Coast and I applied to a couple of schools on the West Coast, and the weather was a lot better on the West Coast. I went to visit schools in April and it was like 22 degrees in Cambridge. And, it was like beautiful and sunny like today is in California. And I was like, okay, I know where I'm going.
Yeah.
So that's what got me out here.
Yeah. Well, and in a world of no bad choices, I feel
very fortunate. I mean, at the time, I will say, in the modern era where it's so hard for people to get visas in the U.S. and stuff, because I wasn't a U.S. citizen, obviously, at the time, and it turned for me back then. It was actually pretty easy to go through the whole thing, get a visa, get citizenship, and all that. I feel for the folks today that don't have a chance to do that as easily.
Yeah, it's amazing how difficult we've made it now. But anyway, that's a conversation for later, maybe. So you get to Stanford. This is in the 80s. And like, it's a really interesting time in Silicon Valley in general. So how did you, I sort of understand, like, you're mostly interested in mechanical engineering and making mechanical things. And Mechi's a good choice because you also get to do like a little bit of electrical engineering and software and whatnot. But like, what was it like at the time? Like, was there this pull at the time towards computer science and symbolic systems and, all of the software stuff that was happening in Silicon Valley? Or
a bit, I would say early days. So for example, my mechanical engineering class had 65 graduating in my year. I think symbolic systems had 6 and computer science had 25. I think now Stanford graduates 400 computer science majors a year.
Yep.
Turns out your good friend Reed was a year behind me. So I was class of 88 and he was class of 89. So I actually knew Reed there, and he was doing this I met him, he's like, I'm symbolic systems major. I'm like, what is that? I've never heard of that thing.
Yeah, I didn't realize you were a senpai though.
Yeah, exactly. But I did mechanical mostly because I thought I'd end up designing cars. And mechanical at the time, I don't know what it's like now, but you did two sequences. You did the thermodynamics sequence, so that basically engine design.
Yep.
And then you did the mechanical design control systems sequence. So I did both. And I interviewed with, actually when I was graduating, I interviewed with a bunch of car companies actually.
And so I'm just sort of curious, and like we'll get back to the interesting stuff. What was the hardest class in Mechie at the time? Because like
partial differential equations.
Yeah.
the math was definitely the hardest. I mean, I was okay at math, but when we get to like partial PDEs, I was like, okay, this is beyond my skill set. So the math was the hardest, I would say.
Yeah.
The others were fun. Like, the nice thing, I think for computer science, it's even more fun today because when you write software, you get feedback immediately for what you've done. Mechanical engineering is not so immediate, but it's pretty immediate, right? Because we had the PRL, or the product realization lab at Stanford. So, you would go in, there's lathes and mills and CNC machines, and you would, CAD out your system, pop it in, and boom, out comes the thing you built. And the thing you built, I mean, you only made one of them, of course, but, you'd get it in a day, which is pretty cool feedback loop, right? Yeah. And so I like that a lot. I like that ability to get quick feedback on what you're doing. And also it's practical because it's very, when you make physical things, it's very tangible. You can see them and feel them.
Yep.
So there was a lot of reinforcement, positive reinforcement in that major.
Yeah, I kind of feel like an old man dispensing advice, but like I think other than aside from actually making things being fun, I think it's necessary. If the reason that you're studying engineering is because you want to make things exist in the world that never existed before, you want to like create some effects, like you actually have to do stuff at some point. And the quicker you can start doing stuff where you are actually making the things that you're trying to understand theoretically, like the quicker you learn and the better your career is going to be. And it always struck me as weird because like when I was learning computer science right around the same time, it was really a fashionable thing to teach computer science in a way where your fingers didn't touch the keyboard. It was like a bunch of analysis. Yeah. And so it's interesting, but like it's just not the same as actually doing a thing.
Yeah, no, I totally agree. I think that, that feedback loop of making something that does, responds then to some behavior that you exhibit is for a lot of people, it's super powerful. You can do a lot of theories of things and understand why they work, but that feedback loop, to me is super powerful. And I think the other thing that I find that, I've graduated with a mechanical engineering. I worked as a mechanical engineer for years, but I've not really been a mechanical engineer for a long time. However, the methodology of saying like, I want a thing to end up doing this for me. In order for it to do this for me, I have to break it into a composite set of parts. And then I have to take each part apart and build and, successively build it so that it plugs in together and then becomes that. That mindset of parsing problems, which is really the engineering mindset, I think it's extraordinarily helpful everywhere. I mean, I find it's helpful in business and thinking about how to achieve business goals and so forth. So foundationally, obviously it'd be great if we graduated more engineers in the world because I think we can always use more. But even if you end up doing something else in life, I still think it's an unbelievable foundation for somebody to start with.
Yeah. And so we've already talked about you being sort of a curious kid. So you were like taking things apart to try to understand how they worked. And, you're just like drawn to complexity, not daunted by it. But were you also a skeptical kid?
Let's see. I wouldn't say that I was extraordinarily skeptical. I mean, I think I didn't like it when people BS'd about things. when people made up stuff that I couldn't then sum up in my own mind.
Yeah.
Right? If you say like it's X, and then you go like, well, how is X composed? And that doesn't really kind of make sense. I didn't like that very much.
Yeah.
But I was aspirational, as in like I always felt drawn to the idea of creating something that doesn't exist today. So in that sense, I did have some skepticism, but I was more motivated by what's around the corner, what's next, what's cool, and how can it be practical, right?
Yeah.
How can it be useful day one? And I'm sure we'll get to some conversation about AI, but there's also a distinction there about like, oh, well, it's this amazing thing over there. But I always try to think about, how is this practical for me today, as opposed to this just pure vision. Like I like aspirational, but I like it to the extent that I can practically apply it to what I do today.
Yep. Yeah. Which I think is, it's a good impulse. So you graduate Stanford, and then you go get a job as a mechanical engineer. What was that job? What were you doing?
I was a product design engineer for HP in the optoelectronics division. So we made HP at the time made various things that used gallium arsenide semiconductor material to create light. And you make a lot of products that create light. That can be everything from displays to automotive components to fiber optic connectors to all sorts of things. But I was an engineer in the group there.
And what did that look like? Because like I think when people hear things like that, like depending on what your background is, you summon up a bunch of different images. Were you sitting at a desk all day, like doing schematics and drawings? Were you in a lab tinkering around with stuff? Were you with customers, like helping them build things?
No, I was pretty much so. And a mechanical engineer's principal tool are CAD/CAM. So HP had its in-house CAD/CAM system. I grew up on AutoCAD and CATIA, which were the kind of industry standards, but HP didn't use those. So I was on ME10, ME30, which at the time ran on workstations, big computers.
Yep.
With your desk, you design this thing. It was a three-dimensional renderer that you did stuff, and you like designed it in various shapes and forms. And then typically you would design one out, you would send it out to the prototyping shop, they would make it, then you would test it. So you would take it into a lab, and in my case, it had to have certain thermal characteristics. So it was an interesting job because it involved both thermal. Well, when semiconductors are pounded hard with electricity, they create heat. When you create heat, the performance degrades, and also it creates, if you involve it with plastic, it melts plastic around it. So I had to do a lot of thermal stuff to make sure that we weren't overheating these systems, and then mechanical design to make them fit into certain mechanical spaces was what I was doing. I would design it. The prototype shop would build it up. We would test it, and then when it was tested enough to our satisfaction, we would send it over to what was called New Product Introduction Engineering, NPIE. Those were the guys that basically took our designs and turned them into a production line that they would make them. At the time, our products were made in Malaysia, so we had a bunch of NPIEs over in Malaysia that would take our product design and then put them in and try to build them. And usually you made something and it didn't work. So then you had to go, spin it another time and do it right. But it was probably, it's a long time ago, but I'd say 30% of the time CAD/CAM, 30% of the time working with other people to, facilitate a bunch of time testing. And test eval was a lot of time, and we had to run a lot of tests that ran long periods of time, and then we had to do temperature chambers to cycle them and those sorts of things. So that was basically the job.
Interesting. And so at some point you made the shift from being a mechanical engineer at a Silicon Valley company to like being more actively involved in software. Like, how did that happen?
Well, I always did a bit of software. So I was programming in BASIC in high school. I programmed a little bit in Fortran, also in high school. I took a bunch of Pascal classes in college.
Yep.
So it was sort of there.
Yep.
It was funny. I was talking to my dad's always been a good advisor, mentor to me, and he mechanical engineering he could understand, but when I was like, well, because when I was thinking of majors, I was like ME, maybe CS. I asked my dad, and he's like, computer science, that's like games and stuff. You don't want to do that. That's a really bad career path. Stick with mechanical engineering, way better. It's like, thanks for the advice, Dad. Really appreciate it.
It worked out for you.
You know, if he hadn't given me the advice, I could be CTO at Microsoft now. So
yeah, you made the right choices, my friend.
But yeah, so I always played around with software. But what actually happened is my boss at HP had an MBA. He was the manager of the engineering group that I was working in. And, you know, he liked me a lot, was very kind to me. And, he was like, you know, for an engineer, you ask a lot of why questions. Like, why are we doing this? This product doesn't seem to make sense. Why, you know, what's the, you know, why are we making this one instead of that one? And why is that division over there? So he said, you should really go and explore the business world to kind of understand it, and you should get an MBA. So my third year, 3 years of engineering, I applied to business schools. And I decided to leave and go to, my manager actually wrote my letter of recommendation, and I decided to go to business school to sort of understand the business likes of it, not knowing what I would do afterwards. I assumed maybe I'd go back to doing what I was doing before, but I'd learn it. I think that's where sometimes in your career you get lucky because doors open. But in my second year of business school, I was organizing a conference, a technology conference for the business school at Stanford. We were inviting these speakers to do things. And originally back then, this is circa early 1994, when you advertised a conference, you would put posters up around campus, say, you know, come by, we have these speakers, whatever. And one of my friends was like, well, we shouldn't do posters, we should do a website. And I was like, what's a website? And they were like, oh, there's this thing called the web. And I was like, oh, like the thing that you do email on? Because we had email. I even had email at work back then, but the web wasn't a thing. And in early 94, what was then Mosaic and then eventually became Netscape had launched the web server web browser. And so instead of making posters, we made a website. And we had a very simple little database where you could enter your email, and then we would then follow up with an invitation on email. And, it got me to exploring the internet, and that, the light bulb went off. Seeing the web, I was like, wow, like nobody's ever going to make posters anymore. It was one of those luminary moments. But no, I sort of got the bug. And then I actually said, like, whatever I'm doing, I have to find a job that has to do with the web. Like, doesn't matter what. And at the time, 94, eBay was started in 95. Yep. Yahoo was started in 95. There were no internet companies in 94. And so then typical engineering mindset, I was like, well, if there's no like web companies, like how's the internet made? And I started doing research on how the internet works. And there's this thing called TCP IP, and there's routers and switches. I was like, well, who makes those? This company called Cisco makes them. So I cold called the CEO. And at the time, you actually called people.
Yeah.
Literally cold called people. And his assistant was nice enough to put me through. And I chatted with him.
This was Craig Chambers at the time?
No, this was still the first CEO was a guy called John Morgridge.
Okay.
John was nice enough to like literally take my call. And he invited me down, and I did a few interviews and got passed around. And finally, the CTO actually of the company, hired me to be sort of technical assistant, basically. It's like, you come and do whatever I tell you to do. And then one thing led to another, but it was literally like that conference and making a website. Like I just, we got on, my friend and I got on, made some HTML stuff, and I was just like hooked.
Yeah, that's all. And so what did that job look like at Cisco? So like you were the TA to the CTO. Like what were some of the technical problems that you all were trying to sort out? 95?
Yeah. So, really 94, 95. So the first context, Cisco was a small company then. It was about 2,000 employees. it was very informal. We had grown up very, very fast as a company. It was a couple $100 million in revenue, I want to say. And so roles were a lot less formal than roles are today in the organization. They basically hired me because there were two technological themes that could affect their core business. They had routing and they had two technological themes. One was broadband to the home.
Yep.
Right. Because back then it was all dial up. And so they wanted to evaluate broadband technologies. And then the other one was that there's a technology that sits right next to routing called switching, which is sort of a more hardware oriented approach to moving packets on the internet, which they were afraid would disrupt routers. Turns out to be true. It did. But they were worried that technology could obsolete routers, and we had to evaluate from a business development perspective whether we should be making acquisitions in that sector. So those are the two projects I got a chance to work on with the CTO. The broadband work led to essentially us partnering and investing with a few of the cable companies to make cable modems. So they were invented at Cisco. And then on the switching side, we ended up acquiring a bunch of companies, like four of them, including Andy Bechtolsheim's company at the time, to build the entire switching product line at Cisco via acquisition. And that turned out to eventually become the largest part of Cisco.
Yeah. That's kind of incredible that you were there helping to sort all of this stuff out strategically right as the internet was beginning to take off.
Yeah. Well, I think what I learned to really appreciate at the time was my boss at the time, the CTO, was very good at sort of seeing, okay, this is what we're doing today. It's great. Business is humming. We love it. But there are things that might happen 2 years from now that will dramatically disrupt what we're doing. And all this happy stuff that's happening now will finish in 3 years if we don't pay attention to that next thing, right? And that, the natural tendency of a business that's going well is to just keep doing what it's doing. And he was very good at saying like that's the exact moment that you have to go and take and lean into the thing that might kill you.
Yeah.
I think I was mostly there helping because he was a big strategic thinker, but it was not very good, not very hands-on. And so I was like hands for him. So he would say like, okay, go explore that one, go do this, talk to this guy over here. And in the process of doing the work for him, osmosis set in. And I was like, oh, that's how I got to look at the world of business. And that's how it works. And it's like being an engineer and you're like sort of sitting there saying, oh, if only we did it this way, this can create another opportunity over here, right? That was the biggest lesson for me at the time.
And so you were at Cisco actually for quite a long while. So 10 years as far as Silicon Valley 10 years ago is, that's a long tenure. I mean, by Microsoft standards, like people stay here for like, we just.
No, it's even longer. So it was 14 years I was there.
Oh, was it? Yeah. So, well, I guess two questions in. So like one, like what made you stay so long when I'm sure every month there was some new opportunity? Like you had this great career. You were probably getting called all the time to come do other things. Like you could have stopped being at Cisco at any point. Like what was the thing that kept you there for as long as you did? And then I'd love to understand, like, when you finally did decide to move on, like, why did you choose what came next?
Net, two reasons, I think. The first was that my role kept changing and I was learning something new. So I was doing more or less what today would characterize as corp dev and strategy work for the first 6 years there until like 2000. And then I was kind of ready to leave at that point. And then John Chambers, who was the CEO, said, well, if you want to be a real, a businessman, you need to own a business. Like you're just sort of like a deal guy. So you should really learn that here. And he gave me the opportunity to take that switching business, which I mentioned a minute ago, that we had assembled through acquisition, and become the general manager for that. that meant I was now, I went from managing like 50 people to managing like 3,000 people. And we were doing everything from chips. So we had teams that were designing the silicon, custom silicon, the electrical engineering, mechanical stuff, thermal stuff, software, core OS software, application layer software, management software, all that stuff in the product, plus product management, product marketing. So it was essentially a GM of that business. And I just thought to myself, well, this is an amazing experience. Like, who gives a kid who's never, like, I literally went from being a IC engineer to managing 3,000 people, less than 10 years later. And I thought this was really good learning. So that, I had that business unit, then they gave me more, and then they gave me more. So every time I thought I was different competitors, different challenges in the market, different customer sets. I went from like selling stuff to Wall Street trading floors to selling the big routers to internet service providers, people like Verizon and Comcast, more customer interaction, which I found super fun. So I felt like I was constantly learning. That was one. And two, and Kevin, I'm guessing you feel some of this as well, being at Microsoft. You are at Cisco is not as much of a center stage company today as it was back then, but then it was very center stage. Like every opportunity, every important event that happened in and around the internet was coming through one way or another. You were touching it. And so you get spoiled because you're at the big boys table. You're sort of like, yeah, I'm really moving the big chess pieces around this thing. And I had a very good relationship with our CEO, and he really brought me into apps. I mean, he was at all the board meetings and everything. And so that was fun. Feeling like it's center stage and I'm learning a lot was amazing.
Yeah.
The thing that got to it is at some point networking lost its glamour. It was sort of like, now you think about networking because the data centers, you go,
oh my God, it's back again, man.
Back again. But for a while there, it got a little sleepy, right? Yeah. It was just like, you plug in, the internet works, who cares? And also I got to age 40. So I ended up spending 14 years there. I started when I was 26. And it was just one of those life moments where like, yeah, am I going to be a lifer here, or is there something else to do in life? So those two, like the sleepiness of the business and the realization that I just had to do something different in life.
So why become an investor?
The investor thing happened later. So I thought I was going to be an operator for a long time. So I ended up joining through some friends that I had at Sequoia. I ended up joining a company in their portfolio called Juiced, which was basically, today you would call that Hulu or Netflix. It was streaming video. I was CEO for 2 years. I learned what I didn't know, which is I understand the tech. I had no clue on the content side. All this stuff about content licensing and rights and copyright and all this stuff, no clue. So it was good tech, terrible content. Company went pretty much nowhere. It ended up getting acquired. And I had gotten, because of my corp dev background, I had gotten a lot of calls from a lot of VCs over the years. And then my good friend Danny Reimer at Index, who was on my board, said, why don't we just give this VC thing a go? And, I had thought about the idea, but I never thought I would be a VC. I liked products, and I thought I'm a product person. But then, maybe it was also a little bit because the startup journey was so shitty. Like it really didn't work. And I felt maybe a little defeated. I was like, well, maybe I'm not a product person. I'm just like a sort of a tech trends kind of a guy. And, I enjoyed my corp dev time and at Cisco, and maybe VC is like that. So, I decided to join forces with Danny and become a venture capitalist.
But like, I do think you are a product guy, and like you're like technical. Like they're just. I mean, I remember one of the first times we met. Like you're citing research papers to me, and like you're constantly reading like a bunch of highly technical literature, and so do you think that has helped you be a better investor, that like you've got this curiosity and like you've got all of the foundation there where you can just sort of dive deep into really gnarly technical stuff?
Yeah, 100%. I mean, what I've learned over the years is that I'm sort of this weird product as a human being that is both very keen on technology and understanding why things work and so forth. But I like to jump around a little bit and see different things with different context. I call that like professional ADHD. But I have both this love of tech and professional ADHD. And the venture thing, I think, worked out because at least the way I prosecuted it, it was always a game of like seeing a lot of different things, seeing how they fit together, understanding how they work. And I do think one of the most important things, there's a lot, you can have very different styles of investors. Some investors are just very good at seeing heat and jumping on it. I fancy myself as an investor that is good at understanding when a technology can actually become a business. And I think in that context, being technical enough, because I can't write code. I mean, I can write a little bit of code, but nothing that would ever become a product. But I can read a paper and know and go like, this is cool, but this doesn't feel like it can be part of a business, or maybe this is a little too early, or it's not far enough along. So that ability to assess a technology's maturity and its ability to become a product is how I've hung my hat as a venture capitalist. And that doesn't mean that's the only style, but for me, it's worked.
Yeah. Well, so I think that's a good segue into AI, because like I think you've made some of the most interesting investments in AI, and I would argue that AI is an especially difficult thing to invest in because it's changing very rapidly. It's kind of complicated. Like there's some strategic stuff that, I think a handful of years ago wasn't obvious at all. That is, that you have to be able to see early, or like otherwise you're going to be too late. Like you invested in Scale, which is like one of the truly interesting data companies. You invested in Cohere, which is like one of the most amazing teams in the era of generative AI that's like building a really interesting business. So, and like, I guess the other thing too that we'll say, like, again, now a lot of this stuff seems obvious, but like a handful of years ago, like almost all of the things that people are excited about right now, most folks, investors and tech executives and lots and lots of super smart people were like, yeah, this is nonsense. Like none of this is going to work. Like, you guys are just full of crap. So like, how did you decide that this was interesting and you wanted to go deep on it?
Yeah. Well, I mean, in some ways you look back at my life and the dots always connect in a similar way. And so what actually happened to me was that I got really interested in Waymo, or back then Google's self-driving program. I thought that was like super technically cool. And even though I was a little skeptical about the timeframes they were talking about, I was very interested in how it worked. So I started doing some research on some of the core elements of the technology there. And the thing that popped up was deep learning for computer vision, right? So and I was like, okay, what is this deep learning thing? So, you wind the tape back and you go back to like ImageNet and AlexNet, and you go back to like basically what machine learning systems look like and how they were applying them in multiple methodologies. Because at the time, self-driving was not one big model, but it was like a series of separated models, some for vision, some for motion planning, and so forth. And that got me pretty interested. And so basically I started chasing ideas around self-driving. Ended up meeting a common friend of ours, Chris Urmson, invested in his company. And that's, one of the beautiful things about investing is that you meet these incredibly smart people and they'll actually teach you how this thing works, right? So I was sitting there with Drew Bagnell, who's the CTO, and he's just like literally giving me a PhD level class on how this stuff works. And they were like, yeah, we need to use labeled data. And I was like, all right, well, label. And so they explained to me why, vision objects need a label. And I was like, well, how do you get labels? And I was like, well, people have to put labels on it. I was like, really? How do you do that? And I was like, well, we use this company called Scale. So I was like, wow, that's interesting. Let me introduce you. So I went and met Alex, and he was like, look, this labeling stuff, it seems mundane, but in order to train machines, you need that. And this is way before LLM. Like LLMs this is 2016, so they hadn't even written the attention paper yet. Google hadn't published their BERT stuff and so forth. So, a lot of it was when Alex Wang was the CEO at Scale, explained to me why this was important. And it just resonated with me that we would need a lot of labels in the world. Like over and over again, we would need them. And people said like, well, we'll do simulation. And I was like, yeah, I don't see how simulation is going to work exactly well here. Like, I think, so I bought the story. We invested in that company. And then, one thing leads to another because you do computer vision, you see robotics. So we invested in Covariant. The Covariant guys are friendly with, Jeff Hinton and the folks at University of Toronto. That's where Cohere is. So we get connected to them. And, one thing leads to another. I think at the time, to be honest, Kevin, a bunch of my partners thought I had lost my marbles, right? Because nobody invested in AI in 2017.
Yeah.
And much less OpenAI was a nonprofit at the time. And people were like, well, how do you invest in a nonprofit that you don't make money in a nonprofit? Big mistake. But it just struck me at the time that humans are, in some sense, the pinnacle of biological technology. Like we are, as far as we know, at the top of the pyramid of biological technology. And I felt like a system would not copied it, but attempted to emulate how humans worked and did so via a computer system had to have a really, really bright future. Like it was sort of like saying the horse is the best instrument we have to move around. If I only could build a mechanical system that mimicked a horse, I could actually improve productivity a lot. And somebody invented a car, right?
Yeah.
And in the same way, like a human is the best brain system that we know of. And if you try to build, you're not like a car is not a horse. They're very different instruments, but they serve a similar purpose.
Yeah.
And that's at least how I think of AI, which is actually AI systems don't really work like the human brain. They sort of loosely, but they serve the same benefit at the end. They just, because of the nature of scaling and computing, they can be much bigger.
Yeah.
And so that's sort of like that light bulb went off and I was like, I don't care what my partners think. This is it. I'm like, we're doing this. And so I did a series of investments and got more and more involved.
Yeah. And it is, I mean, maybe just talk a little bit more about how, I mean, maybe this is a thing that's run through your whole career. Like it's difficult sometimes to like see a thing and have conviction in it and say like, I got to go do this. And like everybody else around you is like, yeah, this is dumb and we don't understand it. And you somehow or another summon something, whether it's contrariness or, like some kind of primal determination or, like cold, rational, calculate, whatever it is. But like, it's sort of tough to row against the current, so to speak. And like, it sounds to me like just sort of listening, to you talk over the past hour, like that's a lot of what you've done over the course of your career.
Yeah, I think, Kevin, maybe you feel some of this stuff at the same way, which is when I'm wrong about stuff, I tend to be wrong because I'm too early on it. Like I see things and I can understand how you can get there, but maybe it takes 5 years instead of 2, and then I'm wrong about it. And so what I try to do in my own mind when I look at things is say, well, that's my natural tendency. I tend to underestimate the amount of time it takes to get there. Applying that filter of bias when I look at something, do I think that it has extraordinary potential, and within a reasonable time frame, can I nail that? If I'm convinced of that, if I'm convinced that it can work in my own sort of architecture in my head, don't really care much about how other people feel about it. Because I think a lot of other people are either too aspirational at times, they're selling you like past the hash pipe type things, or they're in the mindset of like, yeah, that'll never work. Yeah, that'll never work.
Yeah.
Right. It's most people I find are in those corners. And I think that actually a really good way to be a business person is to find that happy medium in our industry. And that's important because the majority of the people are not going to be where you are. So you really have to build your own belief system based on essentially logic of why it is that I believe this. And if I really believe it, first of all, I'm okay being wrong. And by the way, I'm wrong all the time. So having compassion for yourself for being mistaken at times, but also continuing to have the self-confidence to say, I believe in my own logic. I believe that this is going to happen. And that allows you to take certain chances. Honestly, I think in AI, I was maybe a little bit early.
Yeah.
But, more or less it's worked out.
Yeah. And sometimes, you even have to ask yourself as an investor, like whether you're a venture capitalist or you're a chief technology officer, like what the cost of being early versus late is and like where you want to be biased. So yeah, with AI, like I think it's probably worse to be late than it was to be early.
I think you're completely right. I mean, I think today it's very, very tough to be an AI investor. It is very hard. For one, the industry is matured where it's become a large player's game because the capital required is massive. Two, the minute you have an idea, since everybody wants the capital, throw capital behind it, 37 companies appear that do the same thing. So I think it's really hard now. I mean, in some ways, it's like you show up today and you go like, oh, I'm going to do AI. It's like, okay, where's the insight there? Like, being early, you have to convince a lot of people. And you had to do this at Microsoft, I'm sure, when you were thinking through the AI stuff. Like you had to convince a bunch of people that this was worth it because they were saying, it's been done forever. It never works. It's been 30 years. This stuff never works, and you have to be like, no, but this is actually the moment. Trust me, this is the moment. Yeah. And maybe you were probably a little bit on the early side too, but at least you weren't overpopulated with like 1,000 people doing the same thing.
Correct. Yeah. We were early, I think, but like right on the verge. Like if you just sort of look at how things have unfolded, like and there's some things, by the way, where I'm like, I just really desperately wish that I'd been 6 months earlier. Like really, like I mean, it's small handful of things. We can talk about those like off the air, but like there's a handful of things where I'm like, just 6 months made such a tremendous difference. Where it's just a big pain in my ass that like I didn't see it just a little bit sooner. Yeah,
I would say I probably have a few things that I went a little too soon.
Yeah,
but at the end of the day, sometimes you're gonna catch them just right. But the truth of the matter is, you can never in this business tell. And in particular, the world we live in AI, the curve is so steep that it's not it's 6 months in human time, but in technology development time, it's like 4 years, right?
Yeah.
Like so, it is a very tricky thing to pace in time because the rapidity of the velocity of change, the delta is so high right now in this sector.
So maybe last couple of questions. What do you think is interesting going forward, either in AI or, like anything else that's sort of happening in technology that you think is interesting that people ought to be paying more attention to than they are?
Look, I think there's a couple things on the AI side that I pay attention to. One is the physical embodiment of AI, which is interesting. I think the AI we experience through Bing Chat or ChatGPT or Cohere or whatever is a purely digital experience right now. Right. And I think that, we are analog beings. And at some level, there needs to be a physical experience associated with that of some variety. So whether it's robotics, or it's devices, or other things that allow a more physical embodiment of what we perceive to be AI, I think is super interesting. I do pay attention to technologies other than transformers.
Mm-hmm.
I think this is an investor bias. I don't see how investors can, startup investors can win in transformers now anymore because of the capital requirements of it. And I would say for now, there is no obvious scaling boundaries to transformers, but maybe there might be. And if so, might there be a different approach?
Yeah.
Maybe not, but it's my job to explore.
Yeah, and for listeners who may not be AI people, like when Mike's saying Transformers, he's not talking about Optimus Prime. This is the prevailing architecture for deep neural networks that is basically driving all of this crazy scale-based progress right now.
Yeah, exactly. So, I mean, everything that everybody experiences today in AI is largely based on this technology called transformers. And it has very good scaling characteristics, meaning that, if you throw more computing power at it, it just gets better and better and better. That's not generally true with technology. Technology usually has a plateauing effect. Like, you can throw more resources at it, but the pace at which it improves flattens over time.
Yep.
And this particular technology has not shown characteristics of flattening so far. Yeah. But it also means that the resources required get massive. So it means a lot of power, a lot of computers, a lot of data centers, all that stuff. Very hard for a small company to survive. So
it's just very hard for a large company.
Yeah, I'm not kidding. Yeah, good for coal in West Virginia.
Yeah.
So those sorts of things I'm enjoying and trying to pay attention to see, is there something around the corner? Outside of the AI space, I think it's still sort of AI related, but the intersection between AI and medicine is an area that I've been paying a lot of attention to. I think that we're even earlier in the stages of that. I think that that sector of the world will have hopefully a ChatGPT like moment at some point where we we can design a vaccine in 3 weeks, or find a drug that cures or addresses diabetes or something. And that's the other field that I am paying attention to.
Super cool. Well, last question, and I asked this of everyone on the show. So you have this super interesting day job, and you in addition to being an investor, you get to do cool things like be on the board of Ferrari. What do you do outside of work, whatever it is that means, for fun?
I do a little bit of sports just to keep it real. Play tennis, ski, that sort of thing. I read a lot. I actually hate business books. I think I read a lot of them and I'm totally done with them. But I particularly enjoy books that recount either people's lives who had some fascinating involvement with the evolution of technology, or stories about how technology came to fruition, like how a technology became something that's part of our lives. I find those things absolutely fascinating.
Do you have a favorite recent one?
So there's one called that I recently called The Empires of Light, which is the story of the war between Tesla doing AC and Edison doing DC, and how basically Tesla lost. I mean, he died crazy and poor, and Edison won. But actually, the technology Tesla developed turned out to be the right technology. So we all use AC at home, and there's a whole interesting sort of business subtext to the creation of the technology. And there's a lot of, what made Edison a great entrepreneur, maybe not such a great technologist, but a very good entrepreneur. What made Tesla a great technology, but actually a pretty pathetic entrepreneur. his relationship with George Westinghouse and so forth. So fascinating book that really teaches you about how, because oftentimes we sort of simplify and we say like, oh, well, the best technology wins, or the best technology never wins. And neither one is true.
Yeah, correct.
There's a lot of sort of permutation. So that's a fascinating book. And then I go to the occasional Formula One race to enjoy the same thing I enjoyed when I was 6.
That's awesome. Super, super cool. Well, this has been an amazing conversation. Thank you so much for taking time out to chat with us today.
Kevin, it's always a pleasure. We have to do this more often, and maybe we can do the version of this that isn't shielded by Microsoft secrecy in person.
Absolutely. All right, man.
All right, Kevin. Thank you.
Bye.
Okay, well, that was a fantastic conversation with Mike Volpe. And as you were kind of, discussing before your interview with him, his background, I mean, I think is so fascinating because, as you mentioned, he had this experience at Cisco where he was for 14 years. And as you mentioned, it was kind of the center of kind of, the .com kind of boom and kind of the first real internet web boom, and continued to be very successful. And what really struck me, though, was, you have this person who's obviously brilliant, goes to Stanford, studies mechanical engineering, and, is working in engineering at Cisco, and then says, I want to learn about the business, and goes and gets an MBA. I've met a lot of, entrepreneurs. I've met a lot of technologists. I know a number of MBAs. I don't, it's fairly uncommon. Has that been your experience? I don't know a ton of people who haven't had previous, interest in the business side, who are, engineering majors who've decided, now I want to go get my MBA.
Yeah, there's some. I mean, quite famously, my boss is one of them.
Right.
But it is an interesting thing. Like particularly at that point in time when you are sitting, you're sort of sitting in Silicon Valley at one of the boom moments, and maybe that's even a weird thing to say because Silicon Valley's more or less been booming for 5 decades plus now. But the 80s and 90s when he was like an undergrad and grad student were like an especially active time in Silicon Valley, and I know a lot of people who just don't even want to get an undergraduate degree because they're afraid that they're going to miss out on something. And so, I think it's one of the things that I really do respect about Mike is that his curiosity is broad versus narrow. And so he's just constantly trying to fill in the gaps in his experience so that he can give himself even more permission to be more curious. And I think that's what going to B school was about.
Totally.
It's him, being an engineer and realizing, okay, well, engineering without context is not super interesting. So let me go figure out how to get context. And then, as we heard, the more curious you are, I think the more opportunities you create for yourself, because, him being at B school is the thing that created the connection for him to go to Cisco.
Right. No, which again, I mean, I think is so fascinating, right? That he had that curiosity and that kind of instinct to go to the next place, which has clearly set him up for all the stages in his career, both at Cisco doing the, investment and biz dev stuff, and then, as a CEO and now as an investor. I really enjoyed the conversation that the two of you had about being too early versus too late. Because I think that's one of those conversations that people could have kind of endlessly for hours, right? But I did kind of want to ask you, what was it about AI in this moment? Let me be more specific. This moment in AI that we're having, this moment, with transformers and with generative AI and whatnot, that made you make the case to make some of the investments that Microsoft has made, and be one of the earlier people who's kind of involved with that.
Yeah, for me, it was that I saw in 2016, 2017, that that these systems were really doing interesting things as they scaled up, and that they behaved more like a platform with greater scale. And so one of the things that I had been skeptical about with AI, and I have been episodically skeptical about AI for most of my career. So when I was an undergraduate and in grad school, we were in an AI winter. So like we had in the early mid 80s, like people got super enthusiastic about AI, and like lots of energy and lots of people studying it and lots of companies forming, and we had a really catastrophic bust, and this has happened multiple times, like where you've had moments of enthusiasm and then the air goes out of the bubble. It's so frequent, in fact, you can go search for AI winter, and there's a Wikipedia article explaining the bust part of the cycle. And so the thing that I'd had skepticism about for a while is like, if the problem you're trying to solve with AI is like the intellectual exercise of understanding in very precise terms the mechanism of intelligence, which is what a lot of AI had been about. It's like, okay, like we've got this brain, it must be like this subtle symbol processing system, and just like Newton's laws of motion and Einstein's theory of relativity, like there's some mathematical beauty sitting in the neurons and axons in your brain, and like if we just sort of think about it hard enough, like we self reflect, like we're going to find these pure simple rules that explain how cognition works. I was super skeptical that was going to be a thing that goes fast. Because the nature of scientific breakthroughs like that is, it's just sort of slow. Like you go slow and then you have a breakthrough and things, change. But, predicting progress is hard. And what happened in 2017, like particularly with Transformers, is like we had a mechanism whereby things could go fast. And like you didn't actually have to understand the fundamental nature of human cognition. You had this thing that, as you applied scale in data and compute, could emulate parts of human cognition, and the parts that it could emulate were useful enough where you could build a platform on top of it. And so like that's it was a pretty straightforward argument. Like it just seemed blindingly obvious. And, if you are a company like Microsoft that is a technology platform company, and like your job is to equip people to go solve problems with technology, like if this is going to become a platform, you must make sure that it is a great, excellent, part of the overall platform that you're building. Like you can't really have a technology platform, I think, in 2024 without having highly capable AI.
No, definitely not. But certainly that wasn't clear to many people in 2017, except for people like yourself and people like Mike, who were already investing in companies even before some of the seminal papers were being written. So as always, like I'm appreciative of both of your insights, because I think we've obviously needed this, especially as Mike was pointing out, this has become only more capital intensive, and kind of that early era is kind of probably a generational thing where there are very few when I look back in history, like moments to kind of get in at that same stage, and now it's just about identifying the next big waves probably associated with these things.
Yeah, and there's still, I mean, the thing I'll say to everyone who's listening, there's still like an unspeakable amount of stuff to be done. It's just like what folks ought to be thinking about right now is like, how do I go harness the power of this platform to go build amazing new things to solve the education problems and the healthcare problems and the just myriad business problems that you're going to be able to solve now that you've got a new tool in your toolbox to go after them. So like that's to me, the fun stuff. Like I always enjoy, like I derive a whole bunch of satisfaction in building products for other people, building products. But like at the end of the day, like building tools is kind of useless unless people use the tools to do something that matters.
It's so true. It's so true. Like, yeah, for platforms to work, people have to actually use them and want to build things off of them. And I think we're lucky we're in a space right now where people are definitely doing amazing things and are going to continue to do amazing things. And people like Mike are going to continue to invest in those things, and which is great.
For sure.
All right. Well, that is all the time that we have for today. Huge thanks to Mike Volpe for joining us. If you have anything that you would like to share, you can email us at behindthetech@microsoft.com. And you can follow Behind the Tech on your favorite podcast platform, or you can check out full video episodes on YouTube. Thanks for listening.
See you next time.